Hi, here we are at geometry again. We're still exploring circles. We're going to talk about inscribed angles. Inscribed meaning they are inside the circle. If you take a look at these pictures, it's going to show you the different inscribed angles that we have. Angle A here is an inscribed angle. And because it's on the other half of the circle from this arc, the rule here is that it's half of this angle. Then we have this second example with this intercepted arc. Angle A intercepts this arc, and angle B intercepts this arc. So they are both congruent to each other, and they're half that arc length. And then if AC is a diameter, then that means that this angle B that's inscribed intersects this arc, which is 180, and so it's half of that. So the rule here really is that an inscribed angle, an angle that's on the other side of the circle, is half of the measure of the arc that it is intersecting. So our objective here is to find the measure of an inscribed angle and to find the measure of an angle formed by a tangent and a chord. Alright, so fill in the blanks here. An angle whose vertex is on a circle and whose sides are chords of the circle is an inscribed angle. So this angle here, ACB, its vertex is on the circle and its sides are chords of the circle, meaning that it goes from one side to the other, one side to the other. So it's an inscribed angle. And an arc with endpoints on the sides of the inscribed angle and its other points in the interior of the angles is called the intercepted arc. So arc AB is the intercepted arc. In this diagram, angle C intercepts arc AB. Angles formed by intersecting lines have a special relationship to the arcs the intersecting lines intercept. So Theorem 1211, inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So it's really that easy. It's just another rule about circles. We already have a whole bunch, right? The way I remember this one is this angle is on the other half. So far we've done central angles that are on the same half as the arc. This angle is on the other half away from this arc. Therefore, angle B is half of the measure of arc AC. The measure of angle B is half the measure of arc AC. So hypothetically speaking, just making this up here, if arc AC was 60 degrees, then that would mean that angle B would equal half of that. It would be 30 degrees. So let's do an example. In circle O, what is the measure of angle A? Angle A is an inscribed angle. It has its vertex on this side of the circle. It intersects the circle here at this arc. This line is a diameter, so therefore this arc is 180 degrees. So angle A is going to be half of that. The measure of angle A is 1/2 of 180. So the measure of angle A would be, 90 degrees. So what are the measures of angle A, angle B, angle C, and angle D? There's a lot in this picture, and we've been working on dissecting pictures. So let's take a look at each angle at a time. Angle A is here. So angle A has sides that intercept this circle at this arc, BCD. So the measure of angle A would be 1/2 of arc. Now remember that's a major arc because it's more than 180. So BCD, we'll name it by 3 letters. So the measure of angle A is equal to 1/2 of BCD. B to C is 100, C to D is 90. So it's half of 190. So the measure of angle A is equal to half of 190 would be 95 degrees. So we know that angle A is 95 degrees. So now we want to find the measure of angle B. The measure of angle B is this one here. So it intersects the circle at this arc. We can call it CA or AC or CDA. But the measure of angle B is going to be 1/2 of the intercepted arc. And therefore, it's going to be half of that arc AC. I don't need to name it by 3 letters because it's not a major arc. It's a minor arc because it's less than 180. And the measure of angle B is equal to 1/2 of AC is this piece, CD, which is 90, and this piece, DA, which is 64. And when I add 90 and 64, I'm going to get 154. And so the measure of angle B is half of 154. So I am going to get 77 degrees. So the measure of angle B is going to be 77 degrees. Now we want to find the measure of angle C. The measure of angle C is here. It intersects this circle at this arc. This arc, BD. Again, I do not have to name this as a major arc because it is less than 180. So the measure of angle C is going to be 1/2 of the arc it intercepts. It intercepts this arc, BD. And so the measure of angle C is equal to 1/2 of 106 plus 64, 170. So the measure of angle C is equal to half of 170 is going to be 85 degrees. So angle C is 85 degrees. And then finally angle D. Now, because we're so smart, we know that this is a quadrilateral, we could say that we know all 4 of these angles equal 360, or you could use this whole idea of it's the inscribed angle, so angle D intersects this arc, ABC. I called it ABC because it's greater than 180, so it's a major arc. So, let me use a different color here. I need to find the measure of angle D. It's going to be 1/2 of the arc that it intercepts. And so in this case, it's a major arc, A, B, C. So the measure of angle D is equal to 1/2 of 106, and 100 is going to give me a sum of 206. So the measure of angle D is equal to 103. So now I have 4 angles, and they should all together equal 360 degrees. 95 and 85 is 180, and 77 and 103 is 180, so it does. It equals 360. So I know I'm right because it's quadrilateral, right? So these corollaries here. Corollary 1. Remember, corollary is a rule that you can easily prove. Corollary 1. 2 inscribed angles that intercept the same arc are congruent. So angle B and angle A here, they intersect this same arc, so they're congruent to each other. Corollary 2. An inscribed angle in a semicircle is a right angle. So if it has a diameter as its side across from the angle, then you know that this is 90. And then corollary 3. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So if you look back up at that last example that we had, the opposite angles are supplementary, which conveniently worked out for us that it was A and C, right? A and C together equal 180, and B and D together equaled 180. Fancy that. So that's corollary 3. Opposite angles, so B and D together would equal 180, and A and C together would equal 180. They would be supplementary. So using corollaries to find angle measures, what is the measure of each numbered angle here? Well, we're looking for this angle, angle 1. What is this? Well, that's a diameter. So, what's the measure of angle 1? angle 1 intersects this arc, so we don't even need this 40 and this 70 because the measure of angle 1 intersects the semicircle, so it's just 90 degrees. It's really that easy. What is the measure of each numbered angle? We're looking for angle 2. Well, angle 2 intersects this arc. Look at this. This angle intersects this arc. So if this one's 38, then the measure of angle 2, because they intersect the same arc, they're going to be the same measure. Measure of angle 2 is equal to 38 degrees. Again, that easy. The following diagram shows point A moving along the circle until a tangent is formed. Remember, a tangent is a line that is outside a circle and just touches it in one point, a tangent point. From the inscribed angle theorem, you know that in the first three diagrams, the measure of angle A is the half of the measure of angle BAC. So A is half of this arc. A is half of this arc. It's just moving. A is sliding down. A is half of this arc. As the last diagram suggests, this is also true when A and C coincide, when they come together. So, Theorem 12:12, the measure and angle formed by a tangent and a chord is half the measure of the intercepted arc. So a tangent, that's this line here, and it's intersecting at point C, and a chord, angle C, is half of this intercepted arc, this arc right here. For this example, angle C is facing this way, so this angle is half of this intercepted arc. In the diagram, SR is a tangent to the circle at Q. If the measure of PMQ, that's this arc here, is 212, what is the measure of angle PQR? Well, this one requires us to do a little bit of math. You know a whole circle is 360, so you can say that if you know PMQ is 212, then you could find this other arc, right? Because 360 minus 212 will give you that one. Or, so we could do it that way. We could do it that way. 360 minus the arc we know, minus 212 is going to give us 148. So this arc over here measures 148. And so this angle PQR, it would be 1/2 of this arc of 148. So the measure of angle PQR would equal 1/2 of 148 because it's the arc that it's intercepting. It's intercepting that arc. So the measure of angle PQR is equal to 74 degrees. However, we could have done this problem a different way. So let me erase this and show you what we could have done. If we knew that that arc was 212, but we're looking for this angle over here, PQR, we can find the measure of this angle, PQS, and then they're a straight line. They form a linear pair. So we could have done it that way. So we could have said we know that PQS is 1/2 of the arc that it intersects. So 1/2 of 212 is going to be 106. And therefore, these two angles, PQS and this angle, PQR, are a linear pair. So then I could say that I know that 180 minus 106, and I could get to 74 that way too. Either way, we'll practice this more in class. Make sure you write down any questions that you might have.